All right, hello guys and welcome in. Today in this video we're going to walk through a real-world example of kind of building a fixed income portfolio recommendation for our client. And we're going to use a Python script to perform an analysis of three bond alternatives for a specific risk-averse client, being a 68-year-old woman. And the goal is just to run the code, but we're just going to try to understand the story that's around it. So let's kind of go through the code. So let's look at the script. So it's a straightforward kind of linear script, kind of designed for a clear and repeatable analysis. So section one, as always, we have our setup, just kind of importing the things that we need to kind of run and fetch data. And section two is kind of where kind of defining our parameters, as we have here. And kind of we coding the client and market data and like the 32% tax bracket and the 0.5% forecasted rate increase. And then we kind of defined our bond characteristics, and then with the $100 face value and the $20 semi-annual period for all three bonds. And third, we kind of create the dictionaries and encoding terms for each bond, the Treasury, Apple, and California Municipal, and kind of plugging in their unique rates into each one of these. And then for step three, it's kind of just where our calculation engine is. And we kind of build a single powerful function that's the calculate bond analytics. And this function kind of takes a bond's parameters and then uses the MPF rate to calculate its YTM, its yield to maturity, and apply the client's 32% tax bracket to get the after-tax YTM. And we use the npf.pv function to kind of calculate the new lower price of the bond after the 0.5% rate hike. And then finally, we kind of return the percentage price drop as our interest rate risk metric. And then finally, in section 4 is just kind of taking our numbers and executing it. So we kind of use we run the calculate bond analytics and just kind of run everything and get our data. And then after everything, we kind of just look and we validate everything through what we have kind of put in. And this is just for coding purposes. And so we can kind of look and kind of analyze what our outputs are after we kind of run this. So the analysis that we have here, we're kind of breaking down the summary table, like we said, for the 68-year-old client, which is risk averse. And so let's look at the after-tax YTM. So this is like our income signal. So the Treasury gives the client about 3.24 or 3.23, excuse me. And then the Apple gives the client 3.36, and the California bond, municipal bond, if we can get down here, gives us 3.8. So this is our first major insight. So because it's tax exempt, the municipal bond provides the highest actual income to our client by a significant margin, actually. But now let's kind of look at the interest rate risk from the price change column. So we will kind of see that the Treasury will be losing like 3.9 or 3.88 here it shows. And then for Apple, it's showing that it's changing 3.79. And then for California Municipal is 4.03. So this is kind of our conflicting signal. So all three bonds, despite their different coupons, have virtually kind of identical 10-year maturities. Therefore, they all kind of share the same high level of interest rate risk. A 4% drop on a $500,000 portfolio is a $20,000 paper loss, which is our risk averse client. That's not going to work very well. So the problem here is clear. The client wants income, and the California municipal bond is the best for that. But all options, including this one, kind of carry definitely a risk that directly conflicts with the client's risk averse nature. So this kind of brings us to our final verdict and professional recommendation, and which we're kind of going to look at allocation and timing for each of these. So for allocation, we're going to be looking at the clear optimal versus suboptimal choice. So the municipal bond is kind of our clear winner because it's tax-free income. And the treasury bond is the best for the risk-free or the risk-averse portion, as it has zero credit risk. And the Apple bond is probably the worst because of both worlds for the client. So the recommended allocation is 70%, which would be $350,000 of the $500,000 to the California municipal bond for income, and 30% to the U.S. Treasury bond for safety and liquidity. And next, we'll kind of go into timing. So for timing, this is kind of how we're managing the conflicting signal. So we advise that the client doesn't fully invest the 500 grand today. We want to ladder or like kind of dollar cost average the investment. So a prudent strategy would be to invest 200K now in the 70-30 split that we mentioned to start generating income. So we kind of hold the remaining 300K in a high yield savings account, and which is kind of safe from this risk. When the forecasted 0.5% rate hike occurs, the bonds will become cheaper, and then we will then invest the remaining 300,000 at these new lower prices. So locking in a higher yield in the client for the client for the next decade. And this kind of addresses the primary risk that we identified. So kind of to recap, we identified the California municipal bond as the superior income source, but also identified a significant near-term risk. And this is kind of a perfect example of a systematic approach, how that helps you kind of look past the coupon rate for certain numbers and manage kind of conflicting signals and lead to more intelligent, client-focused decisions. So this entire process from parameter definition to the final two-part recommendation kind of gives us a complete actionable investment plan. So thank you guys for joining this week, and we will see you in the next one.